Hi YouTube, Matt from Adventure Sport, and I just wanted to make a quick video today about how to reflow solder an LED emitter. I get a lot of questions about this, and so I figured I might as well make a video and hopefully clear some of this up for people. There's several ways that you can do it, and none of the ways I'm going to show you involve owning $10,000 pieces of equipment. These are all pretty simple things that anybody can do, and we're going to start with the way that I think is a really good way to do it, and then probably move to some of the more unconventional ways of doing it that will also work. Okay, so you've got your MCPCB. This happens to be the copper direct thermal path, which I always use, and I'm going to do some Cree XHP70s today because they're a little bit bigger and they're kind of easier to see, but it's the same method for any of them. The first thing you need to do is figure out the orientation of your positive contact or your negative, whichever. You figure out which way it sits on there. For the XHP70, if you look on the bottom, there is kind of like a little arrow in the center, and you see that little T thing is pointing to the left. On this particular emitter, that is how you're going to know that is the positive. That arrow points to positive things, so you want to make sure that it's going to go on there in that direction. Next thing that we're going to need is some solder paste, and I'm using this Kester EP256 that I got at cmlsupply.com, and it is a no-clean solder paste, which just means that it won't leave behind an acid residue that will eat at your connections. All we got to do is just take this syringe, and I've got the bigger tip that's on there, and you just go across these contacts and put a little bit of your paste. You want to get enough to kind of cover them, but don't get crazy. If you get a little too much, that's okay. If you get not enough, stuff can happen, so you don't want to do that. Okay, so now we're all set there, and we'll put our emitters on in the correct orientation. And what I've got this sitting on here is an electric skillet. This is if you have a hot plate or whatever, anything will work. And I like this because you can control the temperature on it very, very well. You can get it to just enough. All you want is just enough heat to wet the solder, to melt it, and not enough to, burn up your LED and get this, this substrate layer can actually peel off of there if you get this too hot. And I'm going to turn mine, in my particular skillet, I turn it to right about 400 degrees on there, which is what it takes to get this part to where it wets the solder about right and doesn't cook things to death. Basically what will happen is these will just sit there up until the time the solder melts, and you'll be able to see it as soon as it does wet. The emitters will start to move. If they're sitting out here just off, not quite perfect, what'll happen is when the solder does melt, they just kind of suck into place. Something there are ways you could do this that would be a little bit faster, but that's not necessarily better. I like to start with a cold skillet, or at least not a raging hot one, because that gives the LED emitter time to heat up more slowly and things to heat up evenly, as opposed to shocking the emitter. And that isn't a huge problem with the XHP70 LEDs. Cree actually has a formula about how many degrees per second you're supposed to heat up. I don't worry about that too much because I've never had anything that I know of happen doing it this way. Some of the older emitters, like when luminous SST90 emitters, those were a little more popular and we used those, the dome would pop off on those like crazy, and a lot of times that's not what you want, so it was a little more critical then, but you still don't want to shock the emitter too fast. That's why I think that the electric skillet is really an ideal way to do this. And there you go, just like magic, they kind of slide into place. Now, the next thing you want to do is move the emitter around on there just a little bit, and I'm going to show you why. When you need to make sure that the solder is spread evenly between the little pads on the sides and the one in the middle. Otherwise, your LED can be sitting up funny and it's not going to be right. Now, if you've got enough solder on there, what's going to happen is this LED, you saw it slide into place earlier, it's going to bounce like a rubber band if you try to move it. It's going to go boing, 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 boing. You see that? That means we've got enough solder. It's not sitting down on this. It's good. And we've gone crossways to make sure that those solder bubbles are even height. And I'm also going to show you what you don't want. If you did not, I did another one of these and hopefully I got it right here. If you did not get enough solder, what'll happen, you see how it just kind of sits there? There's no boing, 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 boing like that. Even if I go this way, no boing, okay? That's bad. That means you have one or more of the pads where there's not enough solder. And if that does happen, in this one, like I said, I did intentionally. I left it out of the middle section. You can just put a little more on there, and then when it wets, you can spread it around side to side. Now, just because you get a bounce does not mean that your solder is spread evenly. If you've got the two pads on the right and left loaded up and nothing in the middle, it can still bounce like that. But that's why we do this. Now, the next thing that you need to do is you don't want the LED riding up high on this. You don't want it floating in the air. I mean, it's good that we bounced like that, but you don't want to be riding high on several thousandths of an inch of solder. You want it to be as close to that copper MCPCB as possible. So what you do then is this. Just take and give the top of that dome on here a little tap. You see when we go like this, how that kind of pushes out, okay? It popped out the extra solder. Do it just a little bit faster than that. Just go bop on the top, and it'll kind of shoot it out so it's out of your way. And then make sure that you're still sitting on there square, because sometimes doing that can make them sit funny. And if you don't, if you plan to put a gasket around that, some of the LED gaskets for like an XML, they fit right around the edges of that, and you don't want those solder bubbles in your way holding the gasket up, you can just take a toothpick and hold this down and flick those bubbles out. Just make sure that when you flick the bubbles out, you don't slide your PCB over the top of it or they'll stick to it, and then you got to sand off the bottom. Okay, so now that we have that, all you got to do is turn your heat back off and let the emitters cool. While we happen to have this skillet hot, before I shut it off, I'm going to show you one other thing. We did that fresh with all brand new things. But a lot of times, flashlight modders are in a situation where they want to recycle some of their old parts. They want to put a new LED emitter inside of a flashlight that they bought so that they can get more output. And maybe they've either tried before or they're trying to use some other parts. And so I'm going to go ahead and show you real quick how to do that while we're still in the skillet here. Like, say maybe for example you had a copper, you had this, and this you can see there's already some solder on it where this is a recycled PCB. That's one of the copper ones. And let's say I wanted to put this emitter on it. Maybe it's a neutral emitter, and the only way I could order this emitter, it was on one of these little cheap aluminum stars. So basically what you'll want to do then is get your orientation again, and for the XML2, that little black dot in the corner denotes the negative. So I've got my negative side there and my negative side there, and this has already got some solder on it. And because this was used, we pulled the emitter off of that for something else, it's already got some solder on it. Now that solder will re-wet on its own most of the time, but it's not great. So if you're working with that, CML sells this right here, this looks like RF741. They call it rework flux. It's on their website, and it's actually really good. Like, if you just try to use regular liquid no clean flux on that, it pops and splashes, and as soon as you put it there, it just, it goes crazy. It doesn't really do its job. It just kind of beads up. It would do that same thing if I put it there in the center of my thing. But with this, it's kind of a thicker slime, and I think it's probably a higher acid too than the, well, that was plenty. Okay. Higher acid than the other stuff. I spilled a bunch of it in the skillet there. That's great. Anyway, that helps this solder wet at a lower temperature, and it's going to make our lives a lot easier when we transfer that. It's going to, because that other solder will be kind of dry and crunchy if not. So we pull this one here and just stick it on there like that, and we're actually pretty springy there with this particular one already, and I think, yep, see, it drew back. So we're good there. We've got an even solder thing, so we don't need to add any. And of course, we give it the tap. I'm going to flick that little bead out of there, and we're good to go on that. So now we're going to turn off our skillet and just leave the LEDs right there where they're at, and let them cool. Let the temperature come down on them, just like they are, until they're almost cool enough to touch. You can pull them out a little before that. Okay, so now we've got our LEDs cooled down and they're ready to test. And if you're doing a whole bunch of these, rather than having to hook all of them up at once to find out if you did a good job reflowing it, if you've got electrical contact and everything, an easy way to do it is you can use your multimeter. And basically what you do is you want to turn it to the continuity setting, which is that right there on mine. And if you've got it, when you touch the leads together, it'll make that little ringing noise. And for the 3 volt emitters like XML and XPG and everything, you can just go like this. You just touch it, and there you go. Your LED lights up. So that means we're good. This DMM is not going to have enough voltage to do the XHPs, the 6 volt emitters like that, or the MTG2. So I just use my bench power supply. I've got a couple of leads hooked up to that, and I just test them like this. You know, you put about 4.8 volts or so on there, and there we go. All our dyes light up, so we're good to go on these. Both of those worked out just fine. Now, you can see on there, there's a lot of kind of a nasty residue around the edges of those. It's easier to see on the XHPs because they're on that white. And that isn't going to hurt anything because we did use no clean flux. But if you're in a situation where that's going to be visible and you want to get rid of it, what you can do is just clean that off with some of this goof off. It's just a cleaner, and I just put some on a Q-tip. Rubbing alcohol and stuff is not really a strong enough acid. I suppose you could use gasoline or something, but just make sure you don't touch the dome of that LED with this. All you got to do is just wipe along the sides, and you can see there on that side over there we're snow white again. But like I said, make sure you do not touch the dome of your LED with that, because you could actually use this to de-dome emitters. It's that strong, and if you do touch the dome with that goof off, it turns it white and cloudy, and it makes the dome dry and crack, and it's really, really a bad thing. So if you want to clean the dome part of your emitter, just get a Q-tip with rubbing alcohol, and that'll be. But you're really not going to get that much flux on the top of that unless something went wrong. Now, I said there were a couple. If you don't happen to have an electric skillet, I understand that doesn't mean you're outside the loop. It just means you got to think outside the box a little. And there are some other ways that you can still do this that are maybe using things that you already have, and I'm going to show you a couple of those real quick. So one of the ways that I'm going to show is probably my next favorite way. If you don't have a skillet, what you can do is just take a wide piece of aluminum bar. Wider would actually be better than this, but this is what I had. And clamp it in something, put it in your vise or whatever you happen to have, and you can set your PCB on here, just as if it was the skillet. And I like this because it gives you the same opportunity to heat things up slowly. What I would do then is just take my torch like this, and put your solder paste and your LED on there, and then you heat it up like this until the solder wets, and that gives you a similar effect of the kind of slow heat up as what the electric skillet is, because you're going through this metal. You're not putting the heat directly on the PCB, the MCPCB. If you don't have this metal and a torch, you're still not outside the loop. There's still plenty of other ways that you can do this, and this is one we're going to do real quick. Just get you some hemos or whatever you got, a pair of vice grips or something, and clamp this in something. It doesn't have to be a vise, just whatever, and put your solder paste on just like normal. We're doing an XML emitter this time, and so we're going to do our orientation with the little black dot facing the right side, the negative side. And then you've got a couple of choices. Here's something that probably a lot of people have, and that's a heat gun. You can even do these from the top, but you kind of risk blowing the emitter away. Then you can use this, and that will actually get your the bottom of that hot enough, and it does it pretty fast, almost instantly. Also, if you really have nothing else, good old $1.29 cigarette lighter from the grocery store, and you can pull off the same thing. That's really my least favorite way to do it, but you know what? You do what you got to do. There you go. See, just like that, we're wet. Popped out the extra, and you're done. The thing I don't like about that is kind of how fast it does. I guess you could hold the lighter a little further, but really XMLs and most of the Cree LEDs actually are pretty tough, and like I said, I don't know of anything that I've ever had happen because of it doing this. Like I said, usually what will happen if you do shock the emitter is the dome comes loose on them, and that's pretty much it. I hope you guys enjoyed the video. Good lucks on your projects.